So this is the 14th session on rigid body kinematics. So in this also I'll take up a problem on SRC project for velocity. Okay. So I'll write down the problem first. So problem is this. A1, A2 is a rigid rod. A1, A2 is a rigid rod of length L which slides down a fixed inclined plane as shown. Okay. We have to find two things. Find first angular speed omega of rod with respect to ground in terms of given quantities. In terms of given quantities by several methods. And second, find the speed of center C2 of the rod in terms of V. Find the speed of center C2 of the rod in terms of V. In terms of V. Okay. So I draw the diagram here. This is the horizontal ground. This is the fixed inclined plane. This is the rod. This is point A1 of the rod. This is point A2 of the rod. Length of the rod is L. This angle is given to be 30 degree at the given instant. This is the fixed inclined plane. This is the fixed inclined plane. Alright. This is therefore the fixed inclined plane. And this angle is given to be 75 degree. Okay. And this is the horizontal ground, this line. Fixed horizontal ground. Rod end A1 slides on this rod inclined plane downward at a speed V. Okay. So now we have to find the speed of angular speed omega of this rod with respect to ground at the given instant by several different methods. Okay. Now one thing you can see, if end A1 of the rod moves down at a speed V, A2 should move leftward at some speed V2 say. V2 is not given, but we have assumed. Okay. Now first we have to find the angular speed omega of the rod with respect to ground at the given instant. Let us denote it by question mark. Okay, fine. So now omega can be determined by several different methods. SRC also, relative normal speed by separation also. So first what we are going to do is solving by method of by relative normal speed by separation. That concept we are going to use. Okay. So omega is equal to relative normal speed by separation. When normal speed A1, A2 are the 2 points and separation L. Relative normal speed by separation. Relative normal speed by separation. Okay, fine. This I'll grab it. Okay. So now what is the relative normal speed? See, this is 25 degree, this is 30 degree. So this exterior angle of triangle equals sum of two interior opposite angles. So this angle becomes 75 minus 30, that is 45 degree. Now, what is the normal velocity of A1? Velocity of A1 is V down in this way, inclined plane. The normal velocity of A1 is the component of V normal to rod A1, A2. That is simply V sine 45 degree, V by root 2. And what is the normal speed of A2? This is 30 degree, also becomes how much? 30 degree. So normal speed of A2 is how much? V2 sine 30 degree in this direction, V2 by 2. Now both these normal velocities are in opposite direction. So relative normal speed is the sum of speeds by the theory of relative velocity between 2 points. So omega is equal to, this becomes V by root 2 plus V2 by 2 upon separation, which is simply L. Now to know omega, we must know V2 because V and L are both given, but we don't know V2. Now how to find V2? Now A1, A2 are the two material points of the rod. Distance between A1 and A2 is fixed L because the rod is rigid. So component of velocities of A1 and A2 along the line A1, A2, that is along the rod, should be equal. So we'll say V cos 45 degree is equal to V2 cos 30 degree. Cos 30 degree becomes root 3 by 2. So V2 becomes V by root 3 on simplification. Now I substitute this V2 here, this here. So V2 omega becomes V by root 2 plus V2 by 2. V2 becomes V by root 3. V by 2 root 3 upon L. This is omega. Okay. So this will, if you want, you can simplify it or leave it like this. There is no harm. Like V by L, I'll write it as 1 by root 2 plus 1 by 2 root 3. This is answer to omega by first method. Okay. This is solved by using this concept, relative normal speed by separation. Alright. Now we can also solve it by method 2, SRC. By SRC. So SRC you either apply between A1 and A2 and selecting A1, or between A2 and A1 and selecting A2. You can use any one of them. So I am using only one of them. I am selecting A1 and A2 as other point. SRC between A1 and A2. Now SP, A1 arrow becomes the selected point and A2 becomes the other point, OP. Okay, fine. Now what I do, I draw the line joining A1 and A2, which is simply this line. Now this I rub it, okay. So I draw the line joining A1, joining SP and OP, that is A1, A2. I draw this, and this I use this line itself, okay, or I draw it here, okay, fine. Now what action we take? Give the velocity of A1 to A2. Velocity of A1 is how much? V around this. So this I give to this. A2 is here. V I give, okay. This V makes an angle of 75 degree with the horizontal. Now I write down the sentence. Since omega of rod is clockwise, so A2 moves in a clockwise circle with center at A1 and radius L. So for this I give a speed omega L to A2 at right angles to A1, A2. This one. Okay, fine. This I give omega L. Okay. And this is V. Now velocity of A2 is the vector sum of these two. But velocity of A2 is in leftward direction, horizontal direction. It has no vertical component. It has no vertical motion. So component of velocities of these two should cancel out in vertical direction. Alright, fine. So I'll write it here. This is V, 75 degree. Component of V along this direction is V sine 75 degree. V sine 75 degree. Okay, that is same as omega L. Now how much is this angle? This angle is 30 degree. This is 90 degree. So this becomes how much? 60 degree by geometry. So equal to omega L sine 60 degree. Omega L sine of 60 degree it becomes. So this becomes, now this I break as 45 plus 30. 30 degree, okay. Becomes omega L root 3 by 2. Now this I break from sin A plus B formula. Sin A cos B plus cos A sin B. Sin 45 degree. Cos 30. plus cos 45 degree plus sin 30 equal to omega L root 3 by 2. Okay, fine. Omega L root 3 by 2. Okay, now if you solve this, you'll get the value of omega. So on simplifying this, omega becomes how much? I'll write it here. Okay, omega becomes V by L, and 2 goes up and root 3 I divide. So it becomes, on simplifying, 2 by root 3 I multiply. 2 by root 3. 2 by root 3. Just let me check it up once. Okay. 2 by root 3. Sin 45 cos 30 plus cos 35 sin 30. Okay. Omega L sin 60. Omega L sin 60. Okay. Root 3 by 2. 2 by root 3. 2 by root 3 to 1 by root 2. Okay. And 2 by root 3 to 1 by root 2 root 3. I just check the calculation once. Okay. This I'll just check it once. Okay. Just let me check it. V by root 2. V by root 2 equal to, just let me just check the calculation. Okay. V by root 2 equal to V2 root 3 by 2. Okay. So V2 becomes this was a calculation mistake here. V root 2 by root 3. Okay. This was a small calculation mistake was made here. So V2 becomes this. So V2 omega equals to V2. Okay, fine. V2 by 2. V2 by 2, na? Okay, fine. Yes. So root 2 by root 3. Okay. So okay, now it's all right. Yes. Sorry, this is all right. Okay, this is the answer. This becomes 2 by root 3. We can root 2 root 3 root 6. Root 2 into root 3 root 6 becomes, this is root 3. This is just a calculation mistake. I have cleared it here. Root 2 into root 3 becomes root 6. If we just write it here, 1 by root 2 plus 1 by root 6. Same answer we obtained here also. So we have found omega by 2 methods. Okay. Now I'll rub this one. Fine. Now, this omega determined by SRC method and relative normal speed separation method also, same answer. Now, what you have to do in the B part of the question, B part you have to find the speed of center C2 of rod A1, A2. So, best method will be one, you can apply SRC also between center C and A1, or you can also apply that section formula for velocity. I'll use that section formula. Okay. So let V2 be the speed, V2 be the let V0 be the speed of center C of rod, the given rod, of the given rod. Let V0 be the speed of center C of the given rod. Okay. So I'll draw the diagram here. This is A2. This is A1. This is V. This makes an angle of 45 degree with the rod. A2 speed is V2 in leftward direction, as we have found just now. Okay. Fine. And this is the center speed C2. Center C is the center of this rod A1, A2. Now this is L by 2. This is also L by 2. Okay. Midpoint. So we apply the section formula for velocity. In case you have any doubt about the section formula, you can refer to the 12th video on rigid body kinematics. There you get it. Fine. So it is like this. It is like this. See, velocity of VC, just VO here, is equal to lambda times VA1 plus mu times VA2 by lambda plus mu. But since C is the midpoint, lambda and mu are equal. So lambda and mu cancel out, becomes 2. So V0 becomes VA1 plus VA2 by 2. This becomes V0. Fine. Now V0 is the vector sum of these two divided by 2. So magnitude of V0 is found by parallelogram law. Magnitude of VA1 plus VA2. Okay, fine. So this I'll write it here. Fine. So this becomes, now we apply to find this magnitude of this vector sum, we use the parallelogram law of vector addition. So V0 is just equal to 1 by 2 root under VA1 square VA2 square plus 2 VA1 VA2 cos theta, where theta is the angle between VA1 and VA2. Now what is VA1? VA1 is simply V, which is given to us. And what is VA2? VA2 we have determined here. I just rub it here by line, that line constancy of line element magnitude wise. How much was that? I'll just write it again here. V cos 45 degree, that is equal to V2 cos 30 degree. So V2 becomes V root 2 by root 3. This is V2. Okay. So here VA2 becomes this V2. This is VA2. This becomes V root 2 by root 3. Okay. And what is theta? Theta is the angle between VA1 and VA2. Now see, VA1 is in leftward direction. VA2 is in this direction. And VA2 is in this direction. Is it alright what I am saying? VA2 is in this direction, horizontally leftward direction. And V is in this way. So this angle is how much? 75 degree. This is VA1. This is horizontal direction. This is VA2. And VA1 is this. So this angle is 75. This is also 75 degree. So theta is how much? Theta will be equal to 75 degree. Is it alright? Fine. This is VA2. V. VA1 is V and VA2 is this way. That is this way. So this angle is theta. This is 75. So this is also 75 alternate angles. Theta becomes 75 degree. Substitute in this formula, we get V0. So V0 becomes half times root under V square plus VA2 square becomes how much? 2V square by 3. 2 into V root 2 by root 3 cos of 75 degree. This is therefore the required answer. Alright, fine. Now this I'll rub it here. Fine. Now I take V common. So VO becomes, V common becomes V by 2. Root under 1 plus 2 by 3 plus 2 by 3 plus 2 root 2 by root 3. 2 root 2 by root 3. Cos 75 degree becomes, cos 45 degree becomes 30. Cos A, cos B minus sin A, sin B. Cos 45 degree, cos 30. Minus sin 45 degree, sin 30. Okay. This becomes V by 2 root under 5 by 3 plus 2 root 2 by root 3. And this becomes root 3 minus 1 by 2 root 2. Okay. This becomes V by 2 5 by 3 root 3 minus 1 by root 3. Okay. So this is 5 by 3 plus 1, 8 by 3 minus 1 by root 3. Okay. This is therefore the required answer. So V by 2 root under 8 by 3 minus 1 by root 3 is therefore the required answer. This is the required speed of center C2 of the rod A1 A2 in terms of V. Okay. So this also I've discussed. This was the 14th session on rigid body kinematics. Okay. In the next session, I'll take up the case of rolling motion. Okay. That is also very important, extremely important in rigid body mechanics. Okay. So if you go through the examples carefully, you will have complete mastery over this topic. Okay. And then if you take up questions from any other topic, definitely you'll be able to solve them. There is no doubt. Fine. So they say close it here. All right.